The cooling system is also not dissimilar to the cooling of the N55 engine. Click the mouse on the components to obtain more information about the special characteristics of the cooling system. Only one version of the cooling module itself is available. An additional remote radiator is only installed in the right wheel arch in vehicle variants for hot countries equipped with the optional equipment high-speed tuning. The electric fan is part of the heat management and has a nominal capacity of 600 watts. The MAP thermostat is part of the heat management. It is possible to influence the coolant temperature at which the thermostat opens via the electrical heating. The N20 engine features an electric coolant pump with a nominal capacity of 400 watts. It is part of the heat management. The engine oil coolant heat exchanger is mounted on the oil filter module, as is the case with the N55 engine. A remote engine oil cooler does not feature in the versions available at the time of market introduction. The exhaust turbocharger is also cooled by coolant in the N20 engine. To do this effectively, the coolant pump has a run-on capability to ensure that heat continues to be dissipated once the engine has been switched off. The N20 engine features the familiar heat management already used in other engines. Its purpose is to ensure that the optimum coolant temperature is set under all operating conditions. Additionally, the heat management reduces the power of the heating and air conditioning system, and sometimes even the engine, to protect components if the temperatures in the engine are too high. If the temperatures continue to rise, the heat management enters emergency mode. The power output of the engine can be reduced by up to 90% in this mode. Modify the temperatures of the coolant and engine oil to see how the system protection works. Which components are involved in the heat management? Please select the correct responses. Very good. All your responses are correct. The intake and exhaust emission system also bears a striking resemblance to the system in the N55 engine. The N20 engine also features a twin-scroll exhaust turbocharger, for example. Click the mouse on the various components to display more information about them. As with the N55 engine, the DME is mounted on the differentiated air intake system. In this case, however, the DME is mounted on an intermediate plate. This means that the DME can be removed without opening the differentiated air intake system. The intake manifold pressure sensor is located directly behind the throttle valve. Although this is a combined pressure and temperature sensor, only the pressure signal is evaluated. The same sensor, which also functions as the charge air temperature and pressure sensor, is ultimately used for cost-saving purposes. A direct charge air cooler is used with the N20 engine. The heat in the charge air is therefore absorbed by the ambient air directly. A hot film air mass meter is always fitted in the N20 engine and is located directly at the output of the intake silencer. The HFM7 is used in this case, a similar form of which can be found in the N74 engine, for example. A twin-scroll exhaust turbocharger performs the turbocharging operation in the N20 engine. As is the case in all of the more recent petrol engines, it features an electrical blow-off valve and a low-pressure actuated wastegate valve. The catalytic converter, including oxygen sensors, is comparable to the version used in the N55 engine. Only the volume of the catalytic converter has been modified. Two principles are applied when supercharging an engine with an exhaust turbocharger: constant pressure turbocharging and pulse turbocharging. With constant pressure turbocharging, the pressure upstream of the turbine is more or less constant. The energy that drives the exhaust turbocharger is obtained from the difference in the pressures upstream and downstream of the turbine. With pulse turbocharging, rapid intense fluctuations in the turbine pressure occur. When the pressure increases, this generates a pressure wave that strikes the turbine. This method utilizes the kinetic energy of the exhaust gas by creating pressure waves that drive the exhaust turbocharger in a pulsed manner. This enables the exhaust turbocharger to respond quickly, particularly at low engine speeds. Both types of turbocharging are in fact always used in exhaust turbochargers in passenger car engines. The extent to which pulse turbocharging is used depends on the proportions, the exhaust gas ducting systems, and the number of cylinders. The pressure ratios upstream of the turbine depend heavily on the number of cylinders in the engine, among other factors. Let's just take a look now at what happens in one cylinder only. The exhaust valve opens and the exhaust gas is ejected. The exhaust gas strikes the turbine like a wave. The pressure upstream of the turbine increases rapidly, then falls again sharply. With 4 cylinders, a pressure wave strikes the turbine every 180 degrees of crankshaft rotation. The pulse rate increases, but the pressure differences are no longer as great. The pressure waves of the 4 cylinders overlap. Because the pressure difference is small, the amount of pulse turbocharging reduces. The twin-scroll exhaust turbocharger was introduced in order to be able to increase the effectiveness of the pulse turbocharging. It features 2 separate intake ports that are routed separately up to the turbine. This includes an exhaust manifold that connects 2 cylinders in each case. Due to the firing order of the 4-cylinder engine, these are cylinders 1 and 4 and 2 and 3. This method produces pressure ratios in both ducts that are the same as those in a 2-cylinder engine. The pressure differential, and therefore also the amount of pulse turbocharging, is significantly higher. This ensures that the exhaust turbocharger responds quickly, even at low engine speeds. Which sensor signals are evaluated in the intake air system? Please select the correct responses. That is unfortunately incorrect. Please try again. Very good. All your responses are correct. Which cylinders in the N20 engine are connected by the exhaust gas ducts for the twin-scroll exhaust turbocharger? Very good. All your responses are correct. What are the special features of the twin-scroll technology? Please select the correct responses. Very good. All your responses are correct. The N20 engine features a simple vacuum system that contains no new innovations in terms of its design and function. This chapter provides you with a brief overview. Click the mouse on the text to display more information about the components. The principle of the vacuum pump in the N20 engine is a familiar one which is applied in many engines. It is a two-stage pump and has a connection for the brake servo and a connection for the vacuum consumers in the engine. The vacuum reservoir ensures that a sufficient vacuum for operation of the wastegate valve is always available. It is permanently connected to the engine cover. Care should therefore be taken when removing the engine cover to prevent the vacuum lines being damaged. A pressure converter, EDPW, ensures that the wastegate valve is infinitely adjustable. The exhaust flap is also operated via the vacuum system. To do this, a vacuum line is routed to the rear of the vehicle. Which components are involved in the operation of the wastegate valve? Please select the correct responses. Very good. All your responses are correct. There have also been no significant new innovations in terms of fuel preparation. The components used here are mainly established components. The solenoid valve injectors are very similar to those used in the N55 engine. They have the same function and are shaped slightly differently at the top end as the hold-down concept in the engine has changed. However, a special procedure must be used to install and remove them, as the injector shaft is sensitive to pulling and twisting. The high-pressure pump is also a familiar component. It is already used in BMW engines such as the N63 and N74. The high-pressure lines leading to the injectors are no longer screwed to the rail. A permanent soldered connection eliminates the danger of leaks at this point. A fuel low-pressure sensor is not used in the N20 engine. The fuel pump is activated conventionally by the electronic fuel pump control system, EKPS, based on the quantity set by the DME, which largely depends on the engine speed and engine load. Which of these statements applies for the injectors of the N20 engine? Please select the correct responses. Very good. All your responses are correct. The DME used in the N20 engine is the Bosch DME Valvetronic DI, or MEVD 17.2.4 for short. The designation alone shows how closely the DME is related to the MEVD 17.2 of the N55 engine. The DME is mounted on the differentiated air intake system. As is the case in the N55 engine, it is cooled by intake air. Another intermediate plate, which is made of aluminium, is installed between the DME and the differentiated air intake system and ensures an optimum transfer of heat and that the air intake system remains sealed if the DME is removed. The MEVD 17.2.4 features the familiar modular connector concept. Move the mouse over the various connectors to find out what they're for. The N20 engine initially features in the BMW X1 xDrive 28i. The wiring diagram therefore shows the connection with the 2000 vehicle electrical system. The following shows several special characteristics of the sensors on the DME. Click on Info Pool if you wish to find out what any of the connected components are for. The coolant pump and the alternator are connected via the local interconnect network bus, and the intelligent battery sensor is connected via the bit serial data interface, or BSD for short. A new combined oil pressure and temperature sensor is used. It sits directly in the main oil duct of the crankcase and transmits the measured values using a pulse width modulated signal. The temperature signal from the thermal oil level sensor is no longer evaluated. Which of these statements applies for the engine control unit? Please select the correct responses. Very good. All your responses are correct. Which of these statements applies for the connections in the 2000 vehicle electrical system? Please select the correct responses. Very good. All your responses are correct. Which of these statements applies for the oil monitoring system? Please select the correct responses. Very good. All your responses are correct.